Hello everyone. This is a brief introduction to Matlab and a little bit of a tutorial corresponding to Appendix C of the textbook. Again, that appendix is already posted and the files are also posted, so you can basically download the files that I've actually updated here. The reason that I wanted to have this tutorial is there are minor changes that you need to make to those codes that are presented in Appendix C of your textbook, because the newer versions of Matlab are not supporting certain terms in those codes, and that's why actually I wanted to make sure that you are up to date. But what is Matlab in general? How does its environment work? It's fairly simple. There is a command window in which you can actually write anything, like a simple multiplication, say okay, 2 times 3, and then it returns an answer. And basically what it does, it stores the value of the answer in its workspace, as you can see on the right hand side, and that is stored in the variable a and s. So if I say a and s and I just hit enter, it returns that very last amount that is stored in it. So whenever you're working in command window, you cannot write a code in it because you cannot run an entire code in it. You need to write a script and then run it, and that's a big difference here. So command window, you just write something, it returns it as soon as you hit enter, or if it's for the purpose of visualization. For example, if you want to monitor a certain parameter in your code, as you run your code, the numbers will be printed in command window. And the code to clear your command window is CLC. As soon as I hit that, it clears command window, but the workspace remains still not clear. So if you don't want to have a busy command window, you would use CLC. But if you wanted to clear your workspace and you want to sort of clear this memory, you say clear. And if you hit that, you can see the workspace is clear. Still, the command window is not clear. That very last command that I wrote down is already here, so I say CLC. So very basic stuff. But then there is a working folder, as you can see here, and that I have. For you need to select a folder on your computer, and obviously you want to save all the files in the same folder for yourself. Here I have 3 problems from Appendix Appendix C. So I would like to discuss the first problem, which is simply the visualization of an inverted pendulum. And again, it's a visualization. So we'll see how things work, but before that I need to tell you about the script. So if you want to write a script, you create a new script and you can see a window pops up. It pushes down the command window down and it's untitled, so you would want to perhaps create a title here. And if you want to write a code in it, let's say introduce variable x is 3 and variable y is 4, as easy as that, and I would put semicolon at the end of each line because it introduces a new line. So you definitely want to put semicolons in your code at the end of the lines, and I usually put a space before and after any sort of equal sign, plus sign. It's a standard coding sort of fundamental. So anyway, so what this code up to this point does, it assigns number 3 to variable x, 4 to y. So let's save this and say okay, I'll name this as a test, and you can see a test with an extension m file is added to your current folder test. And then how do you run this? There is a run button under the editor tab, and you just click run, and what it does, it ran it in your command window. It mentions that it's just running the test it once was ran, and then the 2 variables are now populated with the corresponding numbers. And if you, for example, say what is x, because x now is existing in the workspace, it's existing in the current memory of MATLAB. So if I say what is x, I just hit enter, it returns x equals 3. And of course you can add other things here. Okay, if I leave this up to this point, it says okay, I'm gonna run line 1, run line 2, and line 3. And because line 3 is not assigned to a new variable, I'm just gonna show it in my command window. I'm gonna tell you what's happening here. So let me clear command window to tell what's happening. Look at that. It says x equals 3, y equals 4. And now, because I didn't introduce a new parameter to assign the result of the summation to, it automatically assigned it to the variable answer, which is used by Matlab, and of course the summation is indicated here. So again, for some of you this might be very basic, but it would be useful for some others. And at the beginning of the code, perhaps you would want to put CLC, and then when you run it, things are already cleared up. If you want to clear your the memory, I would say clear all, perhaps is the better term. It clears the workspace, and then boom, when you run it, answer is here. So if I say okay, now parameter z equals x plus y, next time when I run it, if you keep your eyes here, instead of answer, we don't have answer here. Now it's z because I just assigned z here. But you can see there is a warning here. It says okay, terminate the statement with semicolon to suppress output, because if you're writing longer codes with thousands of calculations, you don't want to print everything in command window. For that reason, we would put a semicolon at the end of this line, and when I run it again, it doesn't show it in the command window, but it's already running it, it's already stored in your workspace, so things are perfect. So this is just one simple example how things are working. But now the question is, okay, how can I add a function, a customized function? What if I want to accept two parameters x, y as inputs of a function and then return something? So that would be next. So for that, I'll open a new script. Either you want to push that plus button up there, or you create a new script here. So in order to create a function, you would write function, and let's have a name for a function. So let's say I would say let's put a name, perform sum. This is the function that I want to use as a name. So that would be the name of my function, and then it accepts two inputs. So let's say a vector u that accepts two inputs, and then I would put end, and automatically Matlab creates this around it. So if I push save, it would save it in my current folder as the perform sum. And one very important note here is, as soon as I save this, of course if I run this function, there is nothing in it, so that name exactly is the same as the name that we are using here, and it is case sensitive. You definitely cannot have a function that has a space in it like this. It simply doesn't work, and that's a very important note to keep in mind. You can see the extension is again m, which is a .m or an m file, but the format of it is function. It's no longer an m file or a script, so that means you cannot run it like this. So if I hit run, it doesn't run anything unless I call this function either in command window or in another script, or perhaps in a Simulink model. So that is the drill here. So if I say, okay, I'm gonna feed my function with two inputs, let's say my first input, or the first element of that input is, which is u obviously, is going to be x, and then y would be the second element of whatever that I feed this function with, and then just calculate some output. Calculate z would be, let's say, x plus y, right? So what does this function? So let me save it, obviously. So what this function does, it accepts a two-element vector u, and then it stores the sum of those two into variable z. So let me hover my mouse here. It says the value assigned to the variable z might not be used, and that's important because I'm just running this basically function eventually, and it's not assigned to anything else. It will be stored in the memory. So let's see what it means. Let's say perform sum of a vector. Of course, vectors are put inside a bracket, and let's say the sum of 3 and 4. So if I do this and if I perform it says a couple of things. So I apparently made a mistake. So look at that. The name of this function is perform sum. There was a typo. That's a perform. So if I hit this, it ran this, and there is nothing. So let me clear again and show you what I meant. So look at that. I ran this, and it ran the function. It did this internal calculation, but you don't see anything in workspace. So it's something that's happening inside this function. You definitely want to define something to be returned to. So we say, okay, z, or the output that we are calculating here is perhaps should be something that we use as the output of this function. So if I save this, if I clear again, and CLC, workspace is empty. So now if I run this function, by the way, I'm using the up or down arrow, key for actually going through the history of the commands that I used here. I hit that, and look at that. Now at least there are some internal calculations. These are local variables. They are not actually occupying anything in my workspace, and therefore the answer or the output of this function is now calculated. And that's how I introduced a function and then used it to perform some simple math here. So now let's look at the example that we have in the appendix of your textbook, which is the inverted pendulum. So let me close all these, and so it is problem 1. So these files are already posted. I have created 3 different files, and one of the functions called, and you can see the logo or the shape of this file is fx, that indicates this is a function. So if I show you what is happening here, I can explain, and of course I encourage everyone to read the appendix to get a good grasp on what is happening here. But before that, let me talk about handle. So perhaps when you see the term handle, what it means, as explained in the appendix, when a graphics function like the plot that is very useful in Matlab is called, the function returns a handle to the plot itself. It's a sort of a graphics handle that's very similar to the idea of an object, or sorry, a pointer in a C++ programming, as explained. So all the properties of a plot or whatever function that we have is sort of passed to that handle, so that later on we can call upon, and that is as easy as that. But first of all, a couple of things. I have created a function that's called drawRod. As you can see, the same name here. It accepts a few inputs. I'm not using a single vector as an input, just I'm individually referring to those inputs. So, and a bunch of calculations with those inputs, and then some plotting. So all it does here, it plots basically x and y. It simply plots a rod, which we will later on see. But if I run this, it's going to come up with an error because it's just a function. It should be called within another script, or inside Simulink, or in another function. So if you look at the plot, this is going to be G, which is a green, and the X and Y data is also presented here. So this if else and, as explained here, is just for some initialization purposes, because the very first second that when you run your Matlab, so this handle variable is empty, and if it's empty, we would use plot, and then later on we'll see how we'll update this plot or redraw again and again as we change variables in our simulation. So again, I'm not going to go into the details of the code. So you will see that, for example, what is the capital variable X or variable Y? Those are basically the corners or some coordinates. So I encourage you guys to thoroughly read the code. But one thing that you will notice is in your textbook, in your appendix, here we have a fill, but now I'm using the term plot, as opposed to a fill function, which is a useful Matlab function to fill an area. But anyway, so we're just plotting, and wherever in the textbook or in the appendixes you see the erase mode and things like that, it's not gonna work. The newer versions of Matlab doesn't work. What I mean here is in your textbook you will see another input mode, and here you will see what? Erase mode. So this is not gonna work because what this erase mode used to do was just to clear the old plot and then redraw some things on it. So what we definitely don't want to use this. So that's why I wanted to give you guys this tutorial to make sure that everyone is on the same page. So this is just drawing a rod for us, and again, the next function would draw a pendulum for us, a base for us, and then we'll draw a pendulum. So here, again, very, very similar to what we have back there. We had a plot, here we have a fill, and again, the erase mode is eliminated compared to the one that we see in your appendix and the textbook. So these are the two functions, draw rod and draw base, that are used inside another function that is, you can see here, I'm calling that function draw rod, draw base, because every time we want to draw this inverted pendulum, so we certainly need to call these two functions that are introduced. They are also located in the same location, same folder, so you definitely want to keep your eyes on that. And a bunch of other initialization. So this function is called draw pendulum. So this is the function that we are going to call in our simulation model. So you would open a model with the extension MDL. You can create a new MDL which prompts you to the Simulink side of the things. So in your Simulink, what you see is something like this. So there is a blank area from your library. You can add different very cool blocks to create your simulation from continuous sources. Commonly used blocks like a I don't know, a subsystem, a terminator. If you have sources like a clock, a constant. So all these Simulink useful Simulink blocks are located in your Simulink library. All you need to do, you need to double click on anything that you want or drag it onto that blank white page that we just saw. One thing that you would want to remember is there are user-defined functions, because obviously we user-defined a function and we need to be able to call that function in our Simulink model. So this is the one, interpreted Matlab function. So we need to double click on this or drag it and to my Simulink model. Hopefully that would be. This is the exact same one, except when you can see it has an input arrow and output arrow. So if I put 0 output, you can see the output disappears, meaning that it's not connected to another element or a plot. If it was a process that we need to use the output data, then definitely we would want to define the number of outputs for that. In this case, I just wanted to show you how it's created. So if I double click on this, look at that. There is output dimension 0. We don't touch anything else here except the function that we want to use or call. It's called draw pendulum. the one that I already have it in my current folder, and when I run this simulation it keeps running that function and a bunch of constants. So obviously this function that we defined accepts a vector of 3 elements, and we use mux and demux, which are here and commonly used. Look at that. So you can actually convert a bunch of variables to a vector. Obviously when you double click on it, it defines number of input and output. Let me show you. But sorry, this is the mux, and then I grab it here. Look at it, double click on it, number of inputs. If I change it to 5, you see that is actually changing to 5 different inputs, and then you can enter or add any sort of input that you want, and then the output would be a vector with those inputs. In here we have 3 constants. So one is the location of the cart, the other one is the angular deflection of the pendulum, and the third one is a clock that defines how this simulation is running, and that's as easy as that. But let me go back to the code that we had, and let me close this library. And as I said, the draw pendulum, which is the function that we are calling in that Simulink model, here accepts 3 inputs, and you can see that's why we use that mux function, and then a bunch of calculations. So when you say the persistent, these are some variable definition. When you want to have something locally calculated within a function, you would use the term persistent. Obviously, whatever that you see in these codes, you're more than welcome to check online and see what's out there. The resources for Matlab is unbelievably perfect and complete on the web, so you're welcome to look at them. But when the first time we call this function, there are some initializations, plotting. So we say, okay, we're gonna name that figure that we run as figure 1, clear the figure, define the width of whatever track that we want to draw so that the block will be moving on it, and so on and so forth. And then initially we draw the base and we draw the rod, we define some axis, and again these are library functions from Matlab, and then we would run these 2 functions again. So again, going back to my Simulink model, so we have this. So when you run the Simulink model, so there is a stop time, so you can put it 10 seconds, 15 seconds, or put infinite or INF. It means that it keeps running on all the way that when you put the stop sign here. So let's see what happens. So when I run, you can see a page figure 1 pops up. There is a pendulum, there is a base and a pendulum, very simple line defining a pendulum, and a track here. So let's see what do we do with this. So let me create this, so then you're able to see what is happening here, hopefully. So there are sliders that you can actually, a slider gain that you can grab from your Simulink library, and what it does is if I change this, you can see the card is moving to wherever actually I'm pushing it. So this is just one way of checking that my animation is working or my graphics is working. If I want to change the angle of that inverted pendulum, I just grab this and I say, okay, increase the angle, or decrease it. And we will see the purpose here is to be able eventually a sketch or a model of your aircraft, and then eventually looping it with dynamics of it, and eventually applying control blocks so that we can control the aircraft and while being able actually to visualize it and see it. And of course here I have the stop button. If I push stop, and then the simulation stops. So I don't need to save this in this point, but that's how these functions are interconnected. Hopefully this will give you a good kickoff for the codes that you see which are posted on Canvas. So this was a very brief intro on that very first example on your Appendix Appendix C. There are two more examples. There is a simple box that is drawn in a wireframe, and then there are patches that are painted sort of or colored in the next coming basically codes that are posted. So I'm sure that if you read the codes now with this background, you're able to relate things perfectly to the codes that are posted. Perfect. Thank you.